with the shifted hyperbolas. All we're doing is just adding an h and a k component to them. One of the things you'll recognize, if you remember from last week, is that the difference with the hyperbola shift versus the ellipse shift is that now what matters is what comes first, the x squared or the y squared. That's what tells you your directions, which direction it's moving. So if the x squared term comes first, it means it's moving left and right. If the y squared term comes first, it means it's moving up and down. The a squared and the b squared no longer really make a difference as far as who's bigger, who's smaller. It's just a squared is the first value, b squared is the second value. That's all that means. Yes, sir?
This is 10.1.
This is 10.6 again. We're shifting, all we do is just shifting the hyperbolas this time around. So what happens in this case here is the only thing that's changing up now is x squared comes first or y squared comes first. H and k still means the same thing. It's still your center. H and k is your center, just like it has been all along. Your a squared term, well, I should say a squared. A is your distance from center to vertex. B is your distance from center to co-vertex, just like it was before. C is still the center to the foci, yep. And then the other thing with the hyperbolas is that it's a squared plus b squared give you c squared. And that's how you set up the hyperbola stuff, all right? The asymptote stuff, you're still going to find, don't worry about a formula for the asymptote itself. What we're going to do is we're just going to walk and go through that rectangular box to write it out. I find that that's the easiest way to do it. There's no point in trying to remember which one's which, if it's B over A or A over B. There's no reason to worry about it. Okay. When we graph these, when you plot them through, there's not a lot of craziness involved. It's just a matter of working with your A's and B's, just like we always have. So what I'm going to do today is just do this a little bit differently. Instead of starting with the graphing, we're going to start with the equations. I don't know, it was something old thing. So here what I want is I'm going to write the equation of a hyperbola that has foci at 5, 2, and 5, negative 6, and vertices at 5, 0, 5, 0, and 5, negative 4. All right. I'm going to write the equation. And we've done these types of problems a lot, and you guys have got pretty decent at them. What's the first thing I'm going to try and do? Graph it.
Wow.
Figure out which way it's going, so that way you can go from there. 5, 2. 5, negative 6. 5 and 0. 5 and negative 4. So which direction is this opening? This is opening up and down. Remember, your vertex always looks at its focus. If it's opening up and down, is it going to be an x squared first or y squared first? Good. So we know it's got to be y minus k, quantity squared, over a squared, minus x minus h, quantity squared, over b squared, is 1. As I go through this, now it's just a matter of plucking stuff out. Now we're going to find that center. Center occurs at the midpoint of either the focus or the vertex. Doesn't matter. So what's 0 plus negative 4? What's happening? Where's your center?
5, negative 2.
So your HK is 5, negative 2. Right. You know what your a squared term is. You know what your c squared term is. So, well, I'm sorry, you don't know what a squared. You know what a is. A is the distance from center to vertex, which is how much? C is your distance from your center to your focus. How much is that?
4.
So a squared is 4. C squared is 16. What's b squared?
Square 12.
12. I need this. I need that. And now it's just a matter of substituting in. What's that? Remember, it's a squared plus b squared. That's our limit.
When you found the center, you did plus
And it's a halfway, yeah, it's the midpoint. I could have done that with the negative 6 and 2 also. I just saw negative 4 and 0, it's be easier. So I fill in the blanks. I get y plus 2 quantity squared over 4 minus, oops, x minus 5 quantity squared over 12 is 1. I'm done. Okay? Very, very, very straightforward. Not a lot of craziness here. Okay? Not a lot of crazies. So, let's graph. I'm going to change this. Let's change this to y plus 4, just to make our lives interesting. Let's graph this. Y plus 4 quantity squared minus x plus 1 quantity squared over 4 equals 1. So we're going to graph and label out all of our parts, just like we've done for all the other types of conics we've looked at. First thing I'm going to want to do is identify my h and k. So that way I can figure out which direction this is going. So what comes first, x squared or y squared in this case? So which direction is this going to go? It's going to go up and down. So what's my h and k?
-1 and -4.
It's -1, -4. I'm glad you made that mistake. Everybody see why it's not -4, -1?
Yes.
Because you guys go too fast. HK goes with the x, then the y. It's a very common mistake. We know this has got to go this way. Your HK is -1, -4. Don't make that mistake again. Okay. Now it's just a matter of listing out your parts. A squared is what? Good. B squared? What's C squared? Good. So we're starting out at -1 and -4. A is plus or minus 1, B is plus or minus 2, C is plus or minus √5. We okay with that? All right. So from that center, I have to go up 1 and down 1 to my vertex. So vertices, -1, -3, -1, -5. Okay with that? Go left and right 4 to get my co-vertices. 2, excuse me. Left and right 2. So my co-vertices will be at -3, -4, 1, -4. Make the rectangular box. Now, in this case here, does everybody agree that I went up 1 and then I moved to the right 2? For that rectangle, we moved up 1, we went right 2. So my slope is 1/2, plus or minus. The reason that I don't memorize if it's A over B or B over A is because I really don't care. Because I have this rectangular box that I just drew, and I can easily count how many I went up and how many I moved over. It's just as easy to do that. Plus, be less likely to screw it up. Yes?
So when we write, like on our exam thing, do you want us to put plus or minus for the slope?
Yeah. Plus or minus for the slope. Right. Okay. So there's our slope. Last thing we have to plot on there is our focus. The focus is the √5. So it's just a little bit more than 2, going up and down. So here was 1, 2, 1, 2. I just have to label those points then. So my focus would be located at -1, and then, what was it, -4 plus root 5, -1, -4, minus root 5. We're doing the same thing like we've done in the past, just adding or subtracting the roots to one of the extra y values. All right. Yes, sir.
Can you go back to the last example?
Let people finish writing this through, or I'll just show you.
So,
This one? Here's that second. That was that one. That's where we got the midpoint, that's why we use that. The midpoint of the vertices is the second. Yes. Yep. Yep. Not a problem. Okay. So like I said, hopefully not so bad, right?
No, not bad.
All right. Do this one then. Let's see where we're at. Hopefully you got something like that.
Yes, I did.
Slopes 3/5. Okay.
Plus or minus.
Plus or minus, very good.
you need where you're starting. You're starting to get to that spot.
That's where he starts.
Yeah.
So if you started in here, you were on the right track. But don't start there. We started over here.
Oh, from the
Okay.
center.
Which leaves us one last thing to look at. Dun dun dun. Oh wait, where's my completing square one?
Oh, I was like, really?
I was saying yes, homework.
I was so excited.
This is the style you guys are gonna screw up.
It's ugly.
Okay? Yeah. I know you guys are gonna mess up on this one. When you're working with hyperbolas and you're completing the square, there's a couple of things you gotta pay very, very close attention to. Now, we have negative 9x squared plus 16y squared plus 54x plus 64y minus 161. We know we're going to have to complete the square here. Okay. when we went to go complete the square, the first thing that we would do is we would regroup our stuff, right? Well, see how we have negative 9x squared? I'm going to put that second. I'm going to put the y squareds first. And then I'm going to put the x squared stuff after. Here's what I do. It works out better. Yeah, it's a little bit cleaner. I'm going to do this. 16y squared plus 64y minus 9x squared plus 54x equals 161. See what I did there? All I did is just rearrange the order in which they were adding, which I can do, because that's the commutative property. 2 plus 3 is 3 plus 2. Yes, ma'am.
So you want the lower,
No, I want the negative.
there's always going to be negative.
Hyperbolas have a subtraction symbol, yes.
Okay.
I want to put that one as the second grouping, that way it's minus that second grouping. It's a lot easier to work with.
So it's not always going to be the minus squares?
Nope.
Okay.
I just wanted to put this value there, that's all. It's easier to have that as the secondary parentheses.
Will it still work though?
Yeah. But then you'd have to rewrite it anyway.
Yeah.
Yeah. Now, when we go to group these things out, can you complete the square of the leading term coefficient not equal to 1?
Yes,
No.
No, you can't do it now.
Factor out the 16. So we have y squared plus 4y blank. Factor out the negative 9. Here's another spot you're going to mess up. Minus 6x. I took out a 16, I took out a negative 9, so I have to put them back in. That's also where you're going to forget. You took out a negative, you got to put back a negative. Okay? Now the easy part. What's half of 4? To square it. So you're going to add 4 to both sides. What's half of negative 6? Square it. So our terms become 16 times the quantity y plus 2 squared minus 9 times the quantity x minus 3 quantity squared equals, I believe you wind up with 144 again. Okay. And then you can add everything out. Oh, we're not done yet. We still have to graph and everything. Okay? Where we're at now? So what comes first, x squared or y squared?
Y squared.
So is this up and down or left and right?
Down.
So we know this is an up and down. What's my h and k?
3 and negative
3, negative 2. Very good. You didn't fall into the trap. Three and negative 2 is the h and k. A squared is b squared. What's c squared?
25.
25. No, that's an ellipse. A hyperbola, it's not. Okay? This winds up being very, very easy to graph. Yes, none of that square root crap, correct. This goes up and down, so A, go up 3, oops, I go down 3, left 4, right 4. Box it in. Asymptotes. Slope of our asymptotes. See, I went up 3, I went over 4, 3/4. Okay. And let's see, all I have left is put in my focus. Remember, this is going up and down, so this is plot our focus up 5. So this was up 3, 4, 5. 3, 4, 5. Do you need me to list out the ordered pairs, or is that something you can accomplish on your own? I hope you can accomplish that. Okay. Ladies and gentlemen, the graph of the hyperbolas when they're shifted or writing these things out is not difficult, as you can tell. There's not a lot going on to them. What happens a lot of times that you guys are going to screw up, like I said, is the flip-flopping your x and your h and your k if the y-squared term comes first, or you're going to screw something up when it comes down to completing the square when you factor out that negative. Just be careful with those. Okay? Questions on that? It wasn't that much on this one. I realized we didn't need to spend extra time on it. So. Yeah, this is the last bit of it. Tomorrow what we're going to do is we're going to talk about the intersection of these things, where two conics can intersect. I know that last year, or excuse me, in your algebra class, you guys talked about how you have two lines intersecting, and you find the ordered pair where those lines intersected. You use, substitution, elimination, things like that. Well, what we're going to do is we're going to look at it in terms of conics. We're going to look at our circle intersecting with a hyperbola, or an ellipse. So if you think about it, a circle and an ellipse could intersect at 2 spots, 3 spots, or 4 spots. Right?
And it's going to be our little sign.
Yep, we'll do that tomorrow. And then you can have, if we do, oh yeah, or 1 spot. If we have hyperbolas, they can intersect ellipses, multiple places, 1 spot, here, there. You can have circles intersecting them 4 places. If I throw all of them in together, we can do a system of 3. We can get up to a lot.
That's okay.
It does look kind of cool. So we'll do stuff like this. You never know. We might even throw a line in here as well. Oops. Might even throw a line in it. The only tricky part about that stuff comes in tomorrow is, if you think about what we're working with a lot of quadratics, a lot of squared terms, which means you could have 2 solutions, which means you'd have to substitute things in twice. So it's not that bad. Yes, sir?
Are we ever going to do
No. Oh, wait, I'm sorry. Yes, you will. But the proofs that we do in here are completely different than what you do.
More like your classes, or like those 2 column proofs?
Your proof, the 2-column proof kind of goes away. Eventually, it depends on what you want to take into college. There is some theoretical stuff you do have to do some proof-based to it. Axiomatic geometry, which is kind of a low-grade geometry class, which is just awful. It's only a 300 level class that most math or engineering majors have to take. What we will do in this class is we'll do some verifying of what are called trig identities, where we're going to do some, it is kind of like a proof, but it's more like a substitution style proof. Okay. How do you get one thing to look like another, that kind of thing. So,
In college, you take this whole thing
that's what that is, that's the axiomatic class. It's awful.
No, everything is